Welcome into today's CAD lesson. In today's exercise, we model the bucket elevator. This is an in-depth tutorial showing how you drive a belt over a shaft. I have several other tutorials I've made with this same method. I'll show you some of them at the end or right here. If you would have any comments, questions, concerns, or contributions, kindly drop them down in the comment section below. I would respond to them as soon as possible. Let's begin with today's exercise. Let's open a worksheet to begin to create this. We click on New App here. Under Part, create 2D and 3D object. This is going to be a part, so we will select the standard MMIPT under the metric template and hit Create. Now what we want to do is to create the path. This is the path we would use even to build our belt, and also we will put some points on there so we can place the bucket rightly on those points. To draw the path, let's pick the 2D sketch command. We want to create this sketch on the XZ plane. Now let's pick the line command. Let's draw a line from this point here. This much is fine. You can drop this here. You can right click OK. Now let's dimension this line. Once you click on that line and drag further away to the right, you will get the vertical dimension. We don't want to change the vertical dimension. We want the aligned length. So you can right click, choose aligned. Now that is what we have. And click again. We want to change this length to 850. Let's enter that. Okay, you can zoom in or double click your scroll mouse button so you can get your work in focus. Let's pick the line command. Let's draw a horizontal line here. You can right click OK. We want to align horizontally the midpoint of this line with the origin. You can right click and then OK also. For this line, let's make it constructional. Now we will dimension the distance between the slanted line we drew and the horizontal line as 45. Let's zoom in. Now let's pick the circle command. Let's draw a circle at the origin. The diameter of this circle is 150. Let's enter that. We'll draw another one at this end point also, and say make equal this circle and this circle. You can right click and OK. This dimension is in a way. Just touch on it. Once you see that icon, you can click and drag the dimension. Right. Now what we want to do is to offset. Let's pick the offset command. Let's offset this line so it is tangential to the circle. The diameter of the circle is 150. So half that is going to be 75. Let's type that in here and enter. We'll also do same on the opposite side. 75. Let's enter. Now you can right click and OK to get off that command. For this line, we will make it constructional. Let's also trim off this part of the circle. Also this part. We'll do same on the opposite side. You can right click and OK. This is going to be our path. On this also we would build the belt like I mentioned. Now let's finish this sketch. Double click your scroll mouse button. Next, we want to put the points. These are the points where we would place the buckets so that they are equally spaced. But we want to put the first bucket about 100 millimeters away from this very point. So first of all, let's put a point here. And then the 100 millimeters, we can put another point here and dimension. That is going to be a little bit too much. So we can put a function. Just click on this option up here that says FX. Here we have all the dimensions we've inputted so far, but we want to add a new one which we've not inputted yet. So we add numeric and type the name you want to give to that. We want to call that the drive. Let's click in here and specify the length of this drive as 100. Now check these two and hit done. Great. Now let's put the first point, which I mentioned will be 100 millimeters away from this point. We can actually pattern this point to get the second one. So let's pick the pattern command and say this is the feature we want to pattern. Select that. The direction that should go should be along this line. Okay. And we want two of them, including the one we have already. Now the distance between them, we say that for this distance, we want to define it with the parameter we listed. So click on list parameter and choose the drive that you just inputted, which is 100 millimeters. Great. For here also, we'll keep the spacing. Let's open this up and we say start that point from this very one. Now we see If you zoom in, you will see that little yellow. So this is where the second point is, and it is 100 millimeters away from this first point. Great. Now, once you see this, just hit OK. Great. So we have our first point and our second point. Let's bring back the visibility of our sketch. Okay. Now for this point, we don't need it anymore. We placed it so we could put the second point so we can turn off the visibility of that work point. Great. Now we also want to pattern this to get the other point where we want to place the bucket. Let's pick the rectangular pattern command. The feature we want to pattern is this one, the direction. It should go along this path. And for the buckets we want 15 buckets. So I'll type that in here. And we want to say that for this distance, we want to define it with the curve length. So make sure it gets 15 of them. However it spaces them along that curve length, we are okay. Right. Now let's open this up and say for the start of those points, I want it to be here. So just click. And for the orientation, we want the orientation to be same as the direction one. And we want the compute also to adjust. So it should adjust it so that it gets the right calculation. Great. Now everything looks fine. Let's hit OK. You wouldn't see those points, but once you hover your mouse on the rectangular pattern, you would see it. Now this is the part, it is ready. This is going to serve as the reference for the build itself. So what we would do is to save this first. I usually prepare a folder before I start to create my project. This is the folder, the bucket elevator. You can also create a folder and save this in there. Now I'll save this as the belt path and create a copy of this belt path. So for that, let's hit open. Let's locate the belt path in here. You can copy that. So right click and copy, and you would paste that in here. Now for the pasted copy, let me rename it as just the belt, which is fine. And let me open that. So just click on that and open it. Now this is the copy. What we want to do is to first of all delete the rectangular pattern. We don't need it. And also delete the other one. Right, now we can start from here. So double click on the sketch. We want to make a little bit modification to this sketch. Now let's offset this inward to a distance of 7.5 and enter that. Now we can finish this and we want to extrude to form the belt. So the extrude command, the profile we want to extrude is going to be this inner one. Let's do that symmetric. The distance of this extrusion is 250. I'll type that in here and hit OK. Now we have our belt. Right, let's save that again. OK, and continue. The third part we want to model will be the buckets. Let's get a worksheet for that new standard MMIPT we will create. We will pick the 2D sketch command and create the sketch on the XY plane. Now let's pick the line command. Let's draw a line here to a length of 50. We would enter that. We'll draw another line perpendicular to that to a length of 75. Let's enter that. Also, we will draw a slanted line to the horizontal line passing through the origin and close this up. You can right click and OK. Let's dimension this length as 50. Okay, and we want to put a fillet. So the fillet command, the fillet radius is going to be 15. We want to put that between this line and this line. Let's close this. The sketch is ready. We will finish this. Now we want to extrude. The extrude command, the profile has been selected. Let's make the direction symmetric and specify the distance of this extrusion as 200 and OK. Now we want to shell this also to form the bucket. So for that, we would use the shell command. The face we want to remove is going to be this face, and we want the thickness that will remain to be about 5 mm, which is OK. Now that is it for this part. We'll go ahead and save it, and to save in the same folder, we'll call this the bucket. Next, we would model the shaft. Let's get a worksheet for that new standard MMIPT we would create. Now let's pick the 2D sketch command, create the sketch also on the XY plane. Let's pick the circle command. We will draw a circle here. For this diameter, I'd like to confirm, so just right click OK. Let's go back to the belt. We are going to put the shaft in here, so we want to measure this radius. For that, we would use the inspect and measure, and want to say that we want to measure this radius. Okay, so it's giving us 67.5, which gives a diameter of 130. Let's press done, go back into the part we are working on. Now we can dimension this with a diameter of 130. Let's enter that. Now we can finish this. Double click your scroll mouse button and we would extrude. The direction should be symmetric. The distance of this is also going to be same as the distance of the belt, which was 250. So I'll type that in here and hit OK. Now on this face, let's create another sketch. Let's pick the circle command and draw a circle here at this point. The diameter is 50. We would enter that. Now let's finish this and extrude this to a distance of 50 also and hit OK. On this face also, I would create another sketch. This time the circle of radius 20. Let's finish this and we would extrude also to a distance of 50. Let's hit OK. Now we want to mirror these two extrusions on the opposite side. So the mirror command, the features are going to be this and that. The plane we want that to go across is going to be the XY plane. We see the preview. So we hit OK. Now let's do a fillet. The fillet radius of 2 mm is fine. We want to apply it to this edge, also this, and the opposite edges as well. Now we can hit OK. Also on this face, let's create another sketch. Let's slice so we see the face. We want to take off any extrusion before that face. That's why we use the slice command. Great. Now let's draw a circle. The diameter of this circle is 90, which is going to be our pitch circle. Right click OK. Now let's select this circle and make it constructional. We want to pick the circle command again and draw a circle here. The diameter 15. Let's enter that and say make vertical the center point of this circle and the origin. Also, we want to make coincident the center point of this circle and this pitch circle. You can right click and OK. Let's finish this and we want to extrude. The boolean is going to be a cut and the depth of that cut will do 5 mm. Let's OK. Now we want to create a circular pattern of this extrusion we've just done. So the circular pattern command, let's pick the feature as the extrusion. The axis we want that to go around, we can use any circular axis. We see the previews of that. We want 6 occurrences or 6 counts, which is fine. So we hit OK. Let's mirror this on the opposite side. So the mirror command, the features are going to be the circular pattern and the extrusion for. So we select the two. And for the mirror plane, we'll go across the XY plane. Let's hit OK. Now we have same on the opposite side. This part is also ready. I'll go ahead and save this in the same folder as the shaft. We have all we need to create the assembly. Let's begin to do that. Let's get an assembly sheet template. Under assembly, assemble 2D and 3D components, standard MMIAM, and create. Now let's change the view and the visual style to shaded with edges. We'll go back to the assembly and we want to put in our first part, and so place. Locate the folder where you've saved your works. The first part we want to bring in will be the path. So just click on that and hit open. Let's click to place that here. You can right click and then OK. Now what we want to do is to constrain this path with the assembly. So open up the planes of the belt part and do same for the assembly. Now we would constrain. The constraint is going to be a flash, and that is going to be between the YZ of the assembly and the YZ of the path. Let's hit apply. We'll do same for the XZ of those two. Let's apply, and then the XY of those two. Let's now apply and we can close this. Now we want to bring in another part. Before we do that, let me suppress the belt path. and even do same for the origins of the assembly. Great. Now let me place. This is going to be the bucket, so I'll open that and place that right here. You can right click and then OK. Now we want to constrain the center point of this with the point we place here. That is going to be the first placement of the bucket. So let's open up the origins of the bucket. Let's open this origin. So it's going to be between the center point here and this point. Let's hit apply. Let's close this and see what is happening. We see this is moving. For that reason, we have to constrain some more. So let's pick the constraint command. This time it's going to be between the bucket and the main assembly. So let me open up the planes for the main assembly. The type is going to be angle and the solution is going to be a directed angle. Because we want to align the planes, all right, but we also want it in such a way that we are able to move the bucket. That's why we are using the directed angle constraints. Right, so that is going to be between, let's see, the XZ of the assembly and also the XZ of the bucket. Let's apply. And then we'll do same also between, let's see, the YZ plane of the assembly and the YZ plane of the bucket. Let's apply and close this. This will be allowed to move, but it's also constrained to those planes, so we can't rotate them when we click. Now let's pattern this along those points we placed. So let me suppress the assembly for now and let's go into pattern, pick rectangular pattern. The component is going to be this one and let's look for those points on the path. So I'll suppress this, open the belt path. Those points, once you click on modeling here, you would see them. So it's going to be the rectangular pattern too. First of all, select the associated feature pattern and you can click on the rectangular pattern too. There we have our buckets placed along those points and hit OK. We can also bring in the belt at this point. So just click place. Let's select the belt. Let's open that. I'll drop that here. You can right click OK. Now we want to constrain the belt, the origins of that with the origins of the assembly. So constraint is also going to be a flash between YZ and YZ. Let's apply XZ, XZ. Let's apply and then XY, XY. Let's apply and close this. I like to keep this model browser clean, so I'll suppress these. Okay, now we can bring in the shaft. And so place, we have the shaft here. I would open that. I'll drop one of them here and the other one there. You can right click OK. Let's constrain concentrically this shaft and this hole here that forms the belt. Let's apply. We'll do same for this. Let me turn this around so I can also select part. Let's apply. Let me get the isometric view. Okay, let's constrain now this face and this one, but we want those two to flash. Let's apply and then we'll do same between this face and now this face. Let's apply and close them. Let's get the isometric view. Okay, let's see. Right, you should be able to rotate this and also you should be able to rotate that. But we want those two to be rotating together. For that, let's put a constraint. It is going to be a motion because we want those two to rotate. The motion should be between this shaft and this one, so you can select those two faces and the ratio between them should be 1. Let's hit apply. The solution is the forward one. Now we can close this. Now let's see, once we rotate one, the other rotates with it. Now we want to fix this rotation, so we would use an angular constraint for that. Let's go into constraints, angle, and directed angle. Now we are going to do that between the origins. Let's open that for the main assembly. We'll also do same for the shaft too. Let's open up its planes. We can do that between, let's see, the XZ plane of the main assembly and the XZ plane of the shaft. Two, let's hit apply and let's close this for now. Now let's see. That rotation is there, but we've used an angular constraint to fix it so we could drive. Let me suppress these for now. Now let's go into our environment. Let's activate our Inventor Studios. The first thing we want to do is to add those parameters we want to animate. So go into FX. The belt path drive is here. So just click on this and you will check that. Let's hit OK. Once you hit on the plus sign next to the animation favorites, now you would have the drive there. Before it wasn't. We just added it. Now let me open up the shaft 2. Let me also add this angular constraint I placed. So you can right click on it and choose add to favorite. There we have it also. Now let's activate our animation timeline. Let's hit OK. This is our animation timeline. If we open this, we realize there's no animation in here. Let's click on animation options and change the length of this animation to 10 seconds. We want to just do 10 seconds and keep a constant speed. Now we can OK. Great. We would animate our first parameter now. That is the angular relationship here. So just click on that, right click and choose animate constraint. For that, we want to start at 0 degrees, which was the constraint we placed between the XZ plane of the shaft and the XZ plane of the main assembly. 0. For the end of that, let's do 2 complete revolutions. That is 360 multiplied by 2, giving us 720. And for the duration of that, or the time, we want that to start at the 0 second and we want the end of that to be at the 10 seconds and hit OK. All right, so once you take the timer to the start and hit play, those two shafts should rotate. So let me just make this smaller and hit play so we see. Okay, so there we have it. Okay, we are rotating in the anti-clockwise direction. So just click in here, right click, choose edit. Now let's change this to a negative. Let's OK. Take the timer to the start and play. Now we are doing the clockwise direction, which is fine for us. Let's stop this, take the timer back. So we can animate the other parameter, which is the drive. Click, right click, and choose animate parameter. For that also, the start of the first bucket we place is 100 mm. We want the length of this, let's do about 1000. Let's make that also start at the 0 second. The duration of that, once we enter the end of 10 seconds, the duration will be inputted. Let's hit OK. So we have that also here. Let's take the timer to the start. Let's hit play. Okay, I think the distance of 1000 was a little bit too much. That's why we see this anomaly here. So let me go into that drive. Let me right click, choose edit. Let's do about 500. Let's hit OK. And now let's play again. Take the timer to the start and play. All right, so that is it. Let me even suppress this and also make this a little bit smaller. Okay, let's increase the size of this. Now what I want you to do is to finish Inventor Studios for now. Let's turn off the visibility of this sketch. You can even apply your appearance at this point. Let me do that. So go into view. Let's change the visual style to shaded with edges. It is that anyway. We'll add a shadow. Let's add a reflection. And for this belt, let's change the appearance of that to the black cast. Type B to move to the B column. We'll pick the black cast. Okay, for the bucket also, let me do Let's see, let me do one of these metal colors. So the metal 2400, I'll do that. And then for these two shafts, let me give that the horned appearance. Okay, this looks much better. Let me turn this around and even this way. Okay, now let's go back into environment, Inventor Studios, animation timeline. This is the timeline. Let's take the timer to the start. Let's hit play. So that is how the bucket elevator works. Once it gets down here, it is able to fetch the grain. It takes it over the belt, and once it gets to the top, it tips it over into a container or a basin. So it's just for moving grains from one point or anything from one point to the other, usually grains. Let's take the timer to the back. Let's play one last time. Okay. Okay, so I don't know if you've noticed. See, we want this face of our bucket to lie on the face of our belt. Let's make that correction. Let me get the isometric view first. Now you can finish Inventor Studios. Let's go back into our work. So let me even collapse the model browser so you see what I'm choosing. Now for these relationships here, let's open that up. You see all your relationships, so the flash, the mate, angles, whatever. This is even good for us to learn how we can edit our work or edit some constraints once we are done with them. So it's good we made this mistake. Now for this angle, let's see, we put that angle between the XZ plane of the main assembly and the XZ plane of the bucket. Let's delete this. And also for this one, see, this is why the bucket is sitting the way it is, but we want it to lie on the belt like I mentioned. So just click on this and also delete it as well. Now let's see what we can do. Let's get the isometric view, and let me turn this around even for a better view. Okay, maybe this way will be fine. Right, now what I want to do is to put a plane, and I want the plane to be angled between two planes. So for that, let me not even select the plane first, just right click, cancel. Now let's see what we want to do. Let's open up the planes of the assembly, and we want to turn on the visibility of this plane. So just click on that, turn on the visibility. We'll do same for the XZ. We'll turn on the visibility. We want to put a plane in between these two. These two planes are at an angle of 90 degrees. We will know that. Let me get the back view. So what we want to do is to put a plane in between these two. Once we select those two, it will put a plane there that would be at the 45-degree angle to both planes. Now let's get the isometric view. Okay, we want to use this plane rather to constrain this face. So let's turn off the visibility of this one. We'll also turn off the visibility of that. We are done with their use. Now let's put our constraints, an angle type, a directed angle. We want to select the first bucket we place. This is it. So this is the face of that bucket, and we want to angle it to this one. So we see now that the bucket is lying on top of that face of the belt. Let's apply. Now we can close this. Let's now turn off the visibility of this plane. We will get the isometric view and go back into our Inventor Studios. So before we do that, let me even turn this way, and I want to maintain this view. So what I would do is to hover on this, right click, and come down to fix distance. So anytime you click on home, this is the particular distance, or this is the particular view you would get. Right, now let's go into environment, Inventor Studios, and let's activate animation timeline. Take the timer to the start and hit play. Okay, so now we have corrected it. Let's see. Okay, This view is even better. Let me take the timer to the start and play again. Great. It happens. It happens. Sometimes you are done with your model, you realize that there are some mistakes you made. So this is how you can go about it. You finish the Inventor Studio, go to the assembly and make those modifications. Once you are done, you come back to Inventor Studios and everything should be fine. I wanted to show you next what I have in store for you. It is this tutorial, and also let's see this as well. I hope you do come back for these. You don't want to miss out on them. Kindly consider subscribing then if you're yet to do that. If you have any comments, questions, concerns, or contribution about this tutorial, you can leave them down in the comment section below. I would respond to them as soon as possible. Don't forget to share this with your card friends and also save this. Give me a thumbs up as well. I'll see you soon in the next tutorial. Bye.